Now we're ready to take a look at 13.2, integration of vector valued functions. So let's take a look. Here's the definition. It's not going to go through these quite as detailed as the other ones for derivatives, but basically, excuse me, when you integrate the definition, if you integrate from A to B, so it would be basically t is in that interval from A to B of r of t dt, then all you got to do is integrate each of the functions with respect to t to get your integrations. Now you are going to get in this plus an arbitrary constant, and you can do a plus c1 and a plus c2 for each of those, or you can just combine those together and then do like a plus c vector, which is like a constant vector that would be on the end. So either way, and we'll do that as we go. So let's take a look. Basically, we're just going to look at examples of integrating and then look at what we call an initial value problem. All right, so let's take a look. Example 1, let's evaluate the integral from 0 to 2 r of t dt if r of t is equal to 12t cubed I plus 4e to the 2tj plus 1 over t plus 1 k. So this is really an exercise in integration. Often this is where I may have you try it, or at least we'll work together on integrating those. So we'll do this one, well, together, I guess. R of t dt is how you would write that. And this is to remind you of notation, right? We haven't actually done integration in this class until now. We've been a month into this, and this is week 5. And we're just starting integration. And you just did differentiation in 13.2 as well. So you integrate all of that, and you can write it in any way you want, really. You can do one integral for the whole thing. I like to write them kind of individually. 12t cubed dt, oops, getting ahead of myself, dti plus the integral of 4e to the 2t dtj plus the integral of 1 over t plus 1 dtk. So integrate all of that individually. So this is just a polynomial, right? Add 1 and divide. This is a exponential, so you just do the u is equal to 2t, du is t dt. So you get the 1 over 2. And then the integral of e is just e's, like we know that. And then what is this one? That's the ln absolute value. Okay, so you need to review your integration, all that. I mean, obviously in this class, this format, you're going to be able to just look stuff up. Some stuff could be timed in the future, but you need to get your... I actually have some integration tables that I like to send out, so I'll send that out soon, because I know we're basically doing some calculus again, and you'll have that to reference. But you don't want to always look stuff up. You got to memorize a certain amount of things otherwise it just gets too bogged down in looking stuff up, and you forget why you're really doing stuff in the first place. You can only cognitively keep so much in your head. All right, enough said. Moving on. So you get 3 t to the 4th I plus 2e to the 2tj plus ln absolute value of t plus 1k. Now all of those you could say inside plus c1, inside plus c2, etc. Or you can just say plus c constant on the outside. So basically then, and this is some notation I want to just throw at you here, you can say r of t, the vector r of t, is equal to all of that, 3t to the fourth I plus 2e to the 2tj plus ln absolute value of t plus 1 k, all right, plus c. So that's your r of t, and when you do your integration, remember how you wrote it like this? You did like 0 to 2, and you said r of t, and so that's basically capital R of 2 minus capital R, vector R of 0. So you always do 2 minus 0. So you do it's always a to b. It's always b minus a. So just remember that. It's always b minus your a. So you want to evaluate that. Substitute in. So check that now. Substitute in 2. And then 0. That'll be 0. That'll be 2. And that'll be... what will that be? That'll be 0. Natural log of 1 is 0. So you get 48i. Oh, and remember the c cancels. This is going way back, I guess. Your c's cancel. You'll subtract and then they're gone. Okay, just to remind you of that. Then you get 2e to the fourth minus 2j plus ln 3k. Okay. Next, let's take a look at this. Where is it? Okay, here we go. So find r of t given r prime of t is equal to t e to the negative t squared I minus e to the negative tj plus k. So we're basically going to use the fundamental theorem to go backwards. We're going to find r of t, and we're given this initial condition, and, don't need a period or comma there, and r of 0. So when t is equal to 0, they give you what that constant is. So r of 0 is 1/2 I minus j plus k. Okay, that's implying when t is 0, you get 1/2 negative 1, 1. So this is usually called an initial value problem. And it gives us a way to find the exact solution to the system, to the equation. Because you get that plus c, and then we'll be able to solve, given this, to find that c. So that's why we do this. All right, so try it. Let me set it up. What you say then is r of t is equal to, and then you're going to integrate r prime of t dt. So that's like basically the fundamental theorem stuff. So if you have the if you have the antiderivative of try that again. Antiderivative of df dt, that's equal to f of t. Right? And then it's a plus c, or you evaluate a to b, and then it's you get f, and you do the b minus f of a. Okay, so so look that stuff up again, integration types concepts, if it's been a while. All right, so try it from here. Okay. So pause it and try it. Let's come back now. You have the integral. And then, so now you're evaluating this. You're doing this integration. So when you do that, you get, well, I wrote it out for you. So you get t, we'll do it, we'll slow down here. T e to the negative t squared I minus e to the negative t j plus k dt. Okay, so now to do, let's see. So how do you do this integration? Well, and this one too, and this will just be t. So you do this, you're going to let u be negative t squared, and then du is equal to negative t 2t dt. And so one of those t's is going to cancel that one. Or you think of it as that t dt is this. Okay, so I did do a little stuff to the side here. So if you pick u to be negative t squared, du is negative 2t dt. Okay, I didn't leave myself enough room. Du is negative 2t dt. So you get du over negative 2 is equal to t dt. So your t dt is right here. Well, it's not there. Oh, here it is. You just do it individually, of course, and then you integrate with the u in there, you just get e. Okay, so check that stuff out. I don't have time to go through all those little details, of course, so you can check it out. So what you get is negative 1/2 e to the negative t squared, and I'll say plus c1. This is how I like to do it and show it. I plus e to the negative t plus c2 k plus t plus c3. Oops, I didn't say jk, sorry. jk. Then you substitute for t equals 0 because that's what is here. So t equals 0, or so this means t equals 0, and then you set it equal to that. So you say for t equal to 0, we have, so substitute in. So now you substitute in that actual value right here. Plug that in and set it equal. So you say negative 1/2 plus c1 I, and then 1 plus c2j plus c3k. And that equals 1/2 I minus j plus k, or 1k. So what you have then is, so all of this, let's try that again. All of this is 1/2. All of this is negative 1. And then C3 is 1. So you get, so then you solve for it. Then you set him equal. So you basically set coefficients equal. So you get negative 1/2. Negative 1/2 plus C1 is equal to 1/2. C1 is 1. 1 plus C2 is equal to negative 1. So C2 is equal to negative 2. And C3 is done. Okay, therefore, r of t is equal to negative a half negative a half e to the negative t squared plus 1 I plus e to the negative t minus 2j, just substituting in now for our c's, and t plus 1 k. Okay. So that does it. That solves for the initial condition of t equals 0 and what's given. And you can see that constant's going to go away as soon as you take the derivative. You can always work backwards, because if you do r prime, these are all gone. But you need to know what they are initially. That's why they're called initial conditions. So, and it's you don't have to use t 0. It just, that's the normal thing to do. You could use t as any number, and what's the value given. Okay, let's look at another one. Okay, I'm just going to show you this one. You're going to do on your own. Okay, so it is this one right here. I'll copy it over, and you can get started on it. It's really that whole page, I guess, huh? Okay. I'll walk you through it. So find r of t given r prime is all of that. This, and that's your initial condition is here. R of 0 is this. Okay. R of t is, so now I integrate all of this. And so I okay, I need to come back to that thing. So, here it's just two examples. Sorry about that. So try this one. Just do this on your own. Try that. And you get 1/2 2t, etc., and then you find your values. So this is just like above. Nothing different. Okay, and then I did another example here. Find velocity and r given your acceleration vector, your initial conditions here for v and r. So you integrate acceleration and get velocity, and then find, so it's a two-step process. This is the first step, this is the second step, to find your initial conditions for v and then r. Okay, so work this one out, and then you'll get your r. So these questions, like that question and the previous one, guaranteed to have that on in this case, a quiz. There's no exam button, or else I'll probably be saying there are just mini exams on the Canvas. So anyway, make sure you know these two cases, and there's other ones in the book for future stuff. Okay, moving on next to 13.3, which is arc length.